final. So I'll turn here so I can see it a little bit better. Hopefully you are looking at our Canvas module, agreed? And this guy here, I'll close it up a little bit, is the only one that will survive on the day of the final. So you will get this one here. And you can see it contains a lot of useful software, so you are allowed to use this, but you are not allowed to use Mathematica or anybody else, all right? But these are mostly graphing things. You're going to upload your work, so there's the Microsoft Lens or any other software you want. But let's start with this fella. Hopefully it'll click in. Okay. Are you looking at what you need to know for the Maths 264 final? Great. PDFs is behaving today. Make it as big as I can. That looks like it. So all the information you need is in that canvas, including this file. Our final exam will be on Thursday. So Monday of next week is officially a school day. You will be given attendance for Monday, so if you don't turn up, I'm assuming you're getting ready for your final anyway, so you're just using your time that way. So you don't. But if you do turn up, it's totally open. You don't know what you don't know until you've had the weekend to figure it out. And so you might turn up on Monday and say, I really do need help on line integrals, right? It's not working, right? Or whatever it is. And once I hopefully answer that for you, you can then say bye-bye. Or you can come and just listen to everybody else's problems because you figure out what they don't know, you probably don't know either, and learn that way. Or you can choose not to come at all. So anyway, back to ours.
Just a quick question. So will there be a quiz this weekend?
Yeah, the quiz for online quiz 10 is due this Sunday. Okay. And it's on, guess what, the last two sections, right? The divergence and Stokes theorem. Tim, are you still stoked to do that homework? Okay. Thought I'd get your joke back on you. So
I'm feeling a little green.
Oh, you got another one then. Okay. Well, you better not diverge from that. So we have 10 a.m. till 1 p.m. That is the time. And there's always going to be a little bit of flexibility with that, but hopefully it's not too bad. You should get it done in 3 hours. That's my goal. You will find a file called final exam here. Right now, if you click on it, it's an empty page, but on the day of the final, when you click on it, the PDF of your final exam is going to be there. And this is the format for your final exam. It's going to have 10 multiple choice questions, 5 points each. So 50 of your 300 point is going to go from there. I don't want to see any working for the multiple choice. All I want to see is on the paper, 1 is A, 2 is B, 3 is C, right? That kind of thing. If it takes you more than, 3-4 minutes to do it, then you're doing it wrong. So pick C. It seems for most people, the multiple choice is the ones you lose most points on for some reason. So just be careful, because there is one right answer, unless I screw up, in which case there's 2 right answers, but don't worry about it. But typically there's one right answer, but all the wrong answers are sensible. Tim, what do you want to ask?
Is there a chance you could send out a grade report at some time?
I was meaning to get one, and just life and broken cars and meetings that I had to attend killed that. So I will send out one. I'll send it out as soon as I can, but that probably won't be until the weekend, and it won't include the last set of homework or the last test, because that won't be due until Sunday anyway, right?
I just like to know how hard I can fail and still get a 2.0.
And I have actually got the spreadsheet part where I know what to do with the data. So what that will tell you, amongst everything else, is you need 120 points in the final, which is worth 300 to get a 2.0, and you need a 280 to get a 4.8, you know, that kind of stuff as well. So it will be pretty inclusive. So it will have lots of stuff. After your 10 multiple choice, there's 10 section 2 questions, right? The big long guys. Everything's chronological. And I don't mean by that there's a question from week 1 and a question from week 10. I just mean the first question's from week 1 and the last question's going to be divergence green theorem, right? That stuff, right? Totally comprehensive, but at least it'll be in chronological order, right? So you can kind of tell if it's question 2, it's probably not going to use week 9 math, right? It's not that kind of question. Here is a list. Wow, pretty impressive. I think we got some missing here. I do. Well, not really, I guess. There's no partial derivatives here or the chain rule, but don't you use partial derivatives everywhere? So it's not like you're not doing it. So, but directional derivatives, max and min. Remember Lagrange? The delta thing, right? The grad of G equals delta, that one. That's that guy.
Actually something I wanted to review.
Okay, we can maybe start that once I've gone through this then. All the double integrals, surface integrals, triple integrals, vector fields, green, curls, Stokes, div, the whole 9 yard stuff, right? So you can see there's a fair chunk of stuff in here. I've told you it's chronological. We are going to have, as you might expect, it's going to be very similar to your midterm. So this is your unique Zoom link for that day. So you get your video going, make sure I can see you, call it good. Once it's finished, you have 30 minutes to upload your working into Canvas. There's a place for it. And the final has to be honest. It has to be a fair reflection of what you know. And so to keep it fair, these are a list of the major things you can and cannot use. You can use your calculator, right? Your TI-84. You cannot use a calculator that, well, we'll do the cannots later. Any written notes you've got, including PDFs, because some of you use Apple things and all your stuff's written in a PDF. I would suggest very, very, very strongly that you have a list of all sorts of things, like a unit circle, right? But not just that. Have, you know, the divergence theorem formula. Have an example of how you would set up a Lagrange. The more structured you do that, the easier it is going to be to find it, right? You might even want to have a list of standard integrals and standard derivatives, because who knows, you may have forgotten that the derivative of 2 to the power of x is a natural log of 2 times 2 to the power of x, just off the top of my head, right? So you got to make sure, you didn't know that, Tessa, did you? Okay, now I've told you, you might want to write it down. Terence, what's the question?
It's not a question, it's a bit of a share. If any of you have a hard copy of either the current textbook or previous one, there's about 8 pages of exactly that sort of stuff in the back, including 120 different forms of integrals. So
I think you can get that in the online textbook too, and I've considered getting that in the online textbook and printing it out.
Okay. Good advice. Organize your notes. If you've just got a pile of 50 pages, you'll run out of time, because it'll take you 20 minutes to find a bit of paper that's got the thing you want on it. So make sure that you've got your notes as structured as you can, just to make it efficient to collect it. But you have good resources there. Anything that's in Canvas is usable. So see that top one I showed you with all the Desmos and the 3D software and that, they're totally good to go. You can use them. Things you can't use. Calculators that do algebraic manipulation. If you don't know what algebraic manipulation is, you don't have one. Or you don't know how to use it, in which case it's still okay, right? Chances are the calculator you've got some kind of TI-84 or basic calculator. So
Is that where it'll do like an answer to fraction? So like if you had 0.66666.
no, it's cleverer than that. You can actually, on these kinds of calculators, that solve equations for you and integrate things. But not just integrate things in the way that the answer's 1.2, because that's what your TI-84 would do, but integrate things like the answer's x cubed sine x. It actually integrates things. Stop doing
so
that.
basically it can calculate using.
Yeah, you
using
type
variables.
it and it will tell you the answer to them. I would know that you were using that and therefore give you 0 points because it doesn't show you the working. So if you go from line 1 to line 9 and I don't see the other 8 in the middle, I'm just going to say, well, that person's cheated. I'm giving you a big fat 0.
So you're telling me that the program I couldn't get to work on a computer, there's a calculator version that probably works for us?
It's a different thing, but yes. So don't use Mathematica. Don't use any of those guys. That's off the
Doesn't
list.
work anyway.
And in some cases, it doesn't. Don't use the internet in any way like that. Don't use it to contact tutoring services or help pages. You can't use things like Mathematica or whatever, or solve equation ones, or, I mean, there are sites out there that can do everything under the sun, right? You cannot communicate with any human being, living or dead, or any software, or any person in Zoom, or by email, pigeon, smoke signals, Morse code, and I've run out of ideas. So basically, don't talk to nothing, nowhere, nobody, right? How about that? Just you and your brain and what you've got with you, right, that you're allowed. WebAssign will be dead. Everything will be gone. So if you go to WebAssign, all you'll see is your PDF. That's all you should have access to. So don't bother going there. And Canvas will be dead. Right, all the videos will be disappeared by then. And so you're not allowed to go and look at videos either. So when that final exam comes, pretty much what you'll probably have is your calculator, a big pile of notes, right, or maybe on a PDF form, but essentially a big pile of notes, and your brain, and you go for it. Any questions? Okay, let's click out of this one.
You're gonna have a Zoom meeting that we're gonna all be in for this, right?
Yes. So let's pull out of this page. Now, that link there, I hope I've got it. Yep. You see, it's just a duplicate of the Zoom link. So that's the one that you come to class on the day of the final for. If you click on that, it should be empty. It is. But that's where the PDF of your final is going to be. See it here? Right. And here's some of the things you want. You want to do you need to see a contour plot. There you go. You want to see a vector field in 3D. This is here for you, right? If you need it. That's a reminder how you upload and use Microsoft Lens if that's what you're going to do to copy your work. Whatever way you do it, it's going to turn into a PDF. If I click on this, start assignment. If it's on OneDrive, you can click on that. I'm doing a file upload. Oh, I don't know how you do that, but interesting. Upload, choose a file, pick the file, open, and submit, and that's it. That's all you need to do. Tessa.
Will you be so gracious as to provide us a practice final that will help us study?
I would love to be so gracious, but to be honest, I don't have time. I'm doing 5 separate classes, which was my own self-inflicted thing. And that means I have 5 different finals, and they are kicking my butt right now. That's one of the reasons I haven't been able to send out your report. It is taking an absolute, and people keep wanting, would you believe I have to turn up for meetings? People keep sending me emails like, I need to go to this meeting. I think that's very antisocial of them.
Rude.
Yeah.
You should just
And I'm
save
now
yourself
going
a
to have
bunch
to,
of time.
yeah.
And just give us all 90% on the final.
Nah.
That would take all the fun out of doing the
would do
final
that.
away.
That would. It would take, and especially if you got 91, you wouldn't want to lose your 1 point. Where was I going with? Anyway, I'm going to have to figure a way of cutting this bit out of the video where I complain about all my meetings. But whatever.
Just give us all the Calc 2 final.
Oh God, I'll tell you, I will have to treble check that, because the way things are going right now, I'm going to be writing that final up to the midnight of the night the exam is on. That's how tight that's I think is going to be. But yeah, that's not your problem. You have got enough problems of your own.
Make sure you
just
don't
doing it.
put Calc 4 questions in the Calc 2 final.
Oh no, that would be amazing.
That would be scary.
It would be funny to see the chaos that would ensue.
Yeah, and I don't think it would be fun when my boss came to me and told me, what the heck are you doing? I've just had 20 emails from irate students. That wouldn't be good. Okay, so there is basically the guide that you need, right? That one there. Right, these three here will disappear. So let's get started. Don't have a lot of time. I guess I should ask maybe first, do we have any questions about the test, the final exam, or whatever? We covered that way? Okay. So I'll zoom over to the white screen and move this a little bit. Okay, what do you want to start with?
Lagrange multipliers.
Lagrange, right? Excuse me. I'm trying to load up the homework from that. That way I can get a question that will work.
Let's see. Questions that were like on our online quizzes and our homework. Those are potential fodder for final exam questions. Or like,
Yeah, that's
so
kind of
like
that's how I'm making my final. I just look at homework and online tests, right? And I say, okay, I kind of like that question, and I do a version of it. So let's see, I'm on the right page. Do a past assignment. And so it's in section 14.7, it looks like. And I do a view on it. Oh, hit the wrong one. Not a problem. Hit the right one. So what you get in these is you're after maximum or minimum values of a multivariate function. So let me pick something that's not a baby one. Okay, let's suppose I do question 3. So we have a function that's equal to this, and there's a constraint attached to it. So we're only interested in points that have 49x squared plus y squared equals 98. So if you're visually trying to think of what exactly you are looking for here, is, can we imagine that the surface xy looks something like that, right? And this fella here is essentially an ellipse. So if I drew the guy, he would look something like this on the ground. and only points on that ellipse, it would get distorted maybe, and it would look like this peanut, right? So what we're trying to do is we are trying to find the biggest Z value. So where on this peanut shape would the highest be? So if I kind of drew the peanut shape, maybe it looks like that. Would you agree that the highest point might be somewhere around here, maybe about there? So when you're being asked to find the max or min, these are the guys you're after. The minimum might be somewhere down there, or it might be a little bit lower, it might be there. So Lagrange says that you only need to solve this system of equations. This fella is him. And the gradient vector is formed by differentiating with respect to x, with respect to y. Lambda is the Lagrange multiplier. And g of x is essentially this guy. The number doesn't matter. So g of xy is going to be 49x squared plus y squared, right? G is your constraint function. If you want to call it 49x squared plus y squared minus 9, you can, because the answer's exactly the same in both cases, right? So far, so good. Oh, almost forgot my little gradient guy there. And so we're going to do that. Now, if I differentiate this function with respect to x, I get y. And if I differentiate this function with respect to y, I get x. If I differentiate this function with respect to x, I get 98x. And if I differentiate this function with respect to y, I get 2y. Are you happy about the derivatives, the gradient guys, where they're coming from? This function with respect to x and y, and then this function with respect to x and y. And then you match them up. So what does that mean? Y, this guy, is lambda 98x, so I'll call it 98 lambda x. And that'll be my equation 1. And x is equal to that, and that. So that's going to be 2 lambda y. And our goal is to solve for x and y, right? Essentially, they're called critical numbers, just like they are in Calc 1. I need to find what values of x and y are these true. Most common thing to do in these questions is to divide. So y divided by x is 98 lambda x over 2 lambda y. And the advantage of doing this dividing technique is, doesn't that remove the lambda from the problem, right? The lambdas disappear every time because there's a lambda in each and they cancel when you divide. In fact, not only do these lambdas cancel, this guy cancels down and gets me 49. So what I'm now looking at is y over x is 49x over y. A little cross multiply, and y squared equals 49x squared. And what you tend to get here are equations like y equals so many x or x equals so many y. In this case, I've got a y squared equal to 49x squared. And you substitute that information into the constraint function. And the constraint function in this case is that 49x squared plus a y squared has to equal 98. So as long as this line here allows you to switch an x into a y or change y's into x's, in this case, would you agree y squared could be replaced by that? You see that y squared here? Can go there. So what I now get is I get 49x squared plus y squared, which is also by coincidence that guy. And now I get 98x squared is 98. Do you see that this is leading to a solution, isn't it? We're going to be able to find an x in a minute. X squared is 1. So that gives me an x of a plus and a minus 1. Right, that's two choices. I could have x equals plus 1. I could have x equals negative 1. So if x equals 1 and y squared is 49x squared, then that makes y squared 49 times 1 squared. That makes y squared 49, and that makes y plus or minus 7. So I now have 1, 7 and 1, negative 7 as two of my critical numbers. If I then use x as negative 1 and plug it into this relationship, I should now be able to get that y is plus or minus 7. So that generates a negative 1, 7 and a negative 1, negative 7. So we have now found all the critical numbers. So far, so good. Right, can anybody remember what we do next? Because remember,
when we submit, like, plug in the coordinates into our main equation, and then figure out which one's the bigger one and which one's the smaller one.
yes. So I guess I'll call it point. And the original function, that one, not the constraint, but that one. And I have a point 1, 7, 1, negative 7, negative 1, 7, and negative 1, negative 7. And for each one of those, I evaluate this. That gets me 7, negative 7, negative 7 again, and 7. So what do we have? We have our maximum, right? And the maximum is what? It's equal to 7, and it happens at these two locations. And these fellas, they're going to be the minimums, right? They're the smallest. And the minimum value is negative 7, and that's going to happen at those 2 points there. And that is an example of using Lagrange multipliers to find a maximum and or minimum value of a function.
Are you able, I don't know if you have to find an actual problem or if you could just kind of think of one, but like when lambda equals 0 would work?
Oh, God, I should have done that as part of my check. If I did, this is what you should always do before you do that. If you plug lambda into 0 here, do you see that the answer you get is x and y are both 0? But 0, 0 does not fit the constraint, and you can't use it. So your question is, can I find one that maybe that's not true for? Okay, let me try that. So suppose I have a constraint function that's x minus 1 squared plus y plus 1 squared equals 9, right? So it's basically a center, a circle off center, right? And let's do as our max min function. Okay, let's change this to 0. I can do that and make that a negative. How about that? Let's see if that would work. Yeah, that'll work. Okay. So suppose this was the function that we were trying to optimize, and that the constraint was that this is true. If you're interested in what that looks like, it's a hyperbola, I believe. Not quite sure where the hyperbola is. I think it's up here somewhere. So,
Did you forget for the bits of the lambda, did you forget the 2 from the power rule?
yeah, put it in there. It's there. This fella here is going to be y, and this guy is going to be x, okay? Now, this one I've constructed just so that we can have a situation where lambda equals 0 actually could be an answer, right? A usable value. Now, if you do lambda equals 0, you get y is 0 and x is 0. Now, my constraint function was the x minus 1 squared, take away y plus 1 squared should be 0. And 0 take away 1 squared, take 0, add 1 squared. Isn't that 1 take away 1, 0? So see, it fits the constraint function. And therefore, that would be one of the critical numbers that you would test for.
Thank you.
It might not be that max or min, but at least it's in the candidacy. It could end up being one of the answers, right? Have we got another topic, or do you want to talk a little bit more about this?
Since this one has like the x minus 1 and the y plus 1, could you, with this example, could you like expand it as if you were finding other critical points, like with the cross multiply, just since this one will be weird with the x minus 1 and then the y plus 1, since this one will kind of end up being like a weird relationship.
I'm not quite sure what you want me to
I'm wanting you to like just take the cross, like do the dividing, like do the cross multiplying, like basically work the y equals 2 lambda x minus 1 and the
okay.
I want that. Gotcha. I want to see that.
Right. So let's suppose we want to. Let's suppose we want to take that question all the way to the end, right? We've already found out that 0, 0 is usable, right? You could get away with using that, right? I'm going to write down the constraint function again because I know I'm going to need some room. So, equation 1, equation 2, the dividing technique is a kind of go-to guy. And the lambdas and the 2's cancel. And so I'm now going to be left with a guy that looks like this. Now, if I cross multiply, I get x times x minus 1 equals y, y plus 1. And I already know I'm in trouble. The question I just created, I won't be able to solve this as an x equals or a y equals. Would you agree this is just not going to play well, right? But I can still change the story. See this guy up here? X, Y didn't do a good job, right? So I'm going to keep everything else the same. I'm just going to change that optimization function to something that does work, right? And so imagine the function f of xy was a half of x squared plus a half of y squared, right? So I'm changing that. Instead of xy, it's that. Now what we would get instead would be, we'd get that guy. Oh, and actually this fella here is just x, and y would equal that guy. So when I do the divide, I get x over y equals x minus 1 over y minus 1. And one of them's a plus, isn't it? Yeah, there we go. Now, cancel, 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 cancel. Cross multiply. Distribute. Subtract an xy from both sides. And do you see that we got lucky? Don't we have a relationship where x can be replaced by negative y? Now, the constraint function was x minus 1 squared, take away y plus 1 squared equals 0. Do you want me to replace the x with negative y, or do you want me to use the equivalent y could be replaced by negative x?
I mean, since we have a squared, it doesn't really matter.
Doesn't really matter, right? So we'll do this one we had first. So it's going to be negative y take away 1 squared, take away y plus 1 squared has to be 0. If you square this whole thing out, whoa, I didn't know I was going to do that. There are no critical numbers in this question, at least the one I've just generated. So the only critical number we've got is 0, 0. Right? Remember, we found out that you could use 0, 0, right? Which means that, what does that mean? It means that, oh, well, you could have it. Can you imagine a shape that has only got a minimum, but it keeps on going upwards forever? Right? So this shape only has one critical number, and it's going to be the value of the function at a 0, 0, which is 0. I'd probably want to put that into, GeoBra and look at it, but evidently this guy here only has a minimum. It goes off forever in the max values. And we have reached the end of today. So I will see some, all, or hopefully I won't see none of you, right? I'll see some of you on Monday, and have good questions for me, and I'll try and go over as much as I can in that time.